examples. So first thing, state if each angle is inscribed, and then if it is, if and only it is, name the angle and the intercepted arc. So looking at AC and CB, AC and AB, those are indeed chords, which means angle CAB is the inscribed angle, and it subtends arc BC. If you look at the next one, K doesn't quite make it to the edge of the circle, so this is not an inscribed angle. Easy. Now, XW, they're trying to fool you here. XW, if you look at it, is a diameter because it passes through the center, but a diameter is still a chord, so indeed angle VXW, or WXV, doesn't matter, right? Which subtends arc VW, or intercepts arc VW, would be the inscribed angle and intercepted arc. If you remember way back to the last type of angle we learned about, M is the center, this angle is created by two radii. This is a central angle, which is not an inscribed angle. So find the measure of the arc or angle indicated. Key thing here is, well, we got this arc, BC, which is created by this angle, angle CAB. We know that twice, 2 times the angle, has got to equal its intercepted or subtended arc, which means that if we divide by 2, that angle is equal to 40 degrees. Conversely, if we are looking at the angle, we know that 2 times that angle is equal to its intercepted arc, which is in this case WV. 2 times 42 is 84, which means that this answer is 84 degrees. So this looks a little bit complicated. Ultimately, we want to know what PD, that is arc PD, is equal to. I would argue that arc PD plus whatever arc FP is would equal arc FPD. Why is that important? Arc FPD is created by this, which is a diameter. So we know that FPD is equal to 180 degrees. And we want to know what PD or DP is, right? PD. And so that's going to remain unknown. Plus, can we figure out FP? And the answer, of course, is, well, this 35 degrees I have to assume is talking about this, which means it's subtending that arc. 2 times 35, which is 70, would be the measure of that arc. So then PD is equal to 180 minus 70, or 110 degrees. That's what the arc is equal to. Okay. Something similar happening here. I see a triangle. I know that this is the arc I'm trying to find, which is intercepted by this angle. If only I knew this angle, I could double it to find the arc. That means I'm going to take 180, which is what all 3 angles in a triangle add up to, as you know. Subtract 49, subtract 70, and that equals 61 degrees, which means that this is 61 degrees. This is equal to 2 times 61, or 122 degrees. And now a little bit more complicated. Find the measure of the arc or angle indicated. So we want this arc here. We know all this information. So we know this arc here is equal to 168. Then we have these angles. So I could figure out what this other part is. That is what all the rest of this is, couldn't I? And the answer would be, of course, whatever 360 minus 168 is. But I also know that if I got this angle here, I know that this arc, and this kind of overlaps here, right, is equal to 2 times that, 2 times 65, or 130 degrees. So I know that arc VFG is equal to 130 degrees. Let me pull this off of here. So pull that back a little bit, right? So you can see what I'm talking about. So we got this overlap. Now this is where it gets a little bit complicated. What's the rest of this? So I have this 119, so more overlap here. This is takes a little bit of doing, would be this whole arc here. That is arc FGH. Now, that means I should be able to figure out what FG is, because I know this part's 168. So then I know that this is 2 times 119, aka 238 degrees. Which means that this piece here, bear with me, this piece here, FG, is equal to 238 minus, oops, not 288, 238 minus 168, which is, break out the calculator, just make sure we get the correct answer here, 70 degrees. So that means this part, this overlap here, is equal to 70 degrees, which means if this part in red is 130 degrees, this part is 70, which leaves how much? Well, what we're trying to figure out, plus 70 equals 130, which means that question mark is 60 degrees. So this next one isn't as bad, believe it or not. We know that this is 95 degrees, and it subtends this arc, which is going to be 2 times 95 degrees, which is 190 degrees. How do I know? 2 times 100, then we take away 5 twice. But that's 190 degrees. What does that mean? We know that question mark plus the 75 they already gave us plus 190 equals what? The whole circle, aka 360. So if we take 360 and we subtract the 190 and we subtract the 75, we get that arc, that is arc SQ, is equal to 95 degrees. So now we're going to throw a little bit of algebra in here. So looking at this, we see an inscribed angle, this 110 degrees, and we see its subtended arc. So if nothing else, you should be looking for, you guessed it, inscribed angles. 110, which means that this is going to be 220 degrees. So I would argue that 220 plus 50 plus this 30x piece has got to equal, let's write that down, is the whole circle, aka 360. So this gives an algebraic equation to solve. So we take the 360, subtract the 220, subtract the 50, and that gets us 30x equal to, I'm just going to double check my numbers so we don't have an error, which would be unfortunate. We get 90 degrees. Divide both sides by 30, x is equal to 30. All they want us to do is solve for x, so once we have x, we're done. Number 12, do you see an inscribed angle? Yes, 31x plus 3. 2 times that inscribed angle is equal to 192. So we must distribute. So let's call that 62x plus 6 equals 192. Subtract 6. So 62x equals 186. Then we divide by 62, which means x equals 3. So we're just using this as an excuse to set up an equation that we can then solve. We've done this stuff before. So these next couple are a little bit more complicated, but if you take a look at NLM, angle NLM, if I knew what x was, right, then I could figure out what this arc is by plugging in x, and then take half of that to figure out angle NLM. But first, I have to recognize, and there goes the dogs, that ln is a diameter. So I know that 13x minus 10 plus 7x minus 10 has got to equal 180, which means 20x minus 20 equals 180, or 20x equals 200. So x equals, drum roll or not, 10. If this is 10, 7 times 10 minus 10 is equal to 70 minus 10, or 60 degrees. If this arc is 60 degrees, that makes angle NLM half of that, or angle NLM, NLM is equal to 30 degrees. Similar logic here for the next one. Let's make a little coordinate off there. What do we know? Well, we know that, and this is where something interesting is going to happen. We know that 38x plus 5 subtends this whole thing. And that's what the 38x plus 5 subtends. And this inscribed angle here, 21x minus 2, describes this. That means that if I take 2 times 21x minus 2 and add 2 times 38x plus 5, that would equal, well, the whole circle, aka 360. Now I'm going to do something tricky. I'm going to divide this by 2, divide this by 2, and divide this by 2, which means that 21x minus 2 plus 38x plus 5 equals 180. Now here's something interesting. If you look carefully, hopefully, you see quadrilateral GHAF. GHAF, yes. This looks like, well, it's a quadrilateral that is formed by 4 chords. We could say that's an inscribed quadrilateral. So it looks like if these two opposite angles, when you add them up, equal 180 degrees. What does this enable us to do? Well, we set up this equation. 21x plus 38 is 59x. Negative 2 plus 5 is plus 3 equals 180. Subtract 3. We get not 157, 177. 177. So we know that 59x equals 177. Divide both sides by 59. X equals, I believe it's 60. Let's see. Sorry, 3. I know where I was going with that, honest. Now this is where I have to be careful. We know x equals 3, but they want the measure of arc FGH. That is the arc subtended by 38x plus 5. So if I plug 3 into 38x plus 5, 38 times 3 plus 5, I get 119 degrees, which means that arc FGH would be equal to 2 times 119, or 238 degrees. So twice that subtended arc. That's twice the inscribed angle equals the subtended arc. Now, these problems are a bit of a challenge, but I'm going to use similar logic to what I did in 14, as in, I know that this is an inscribed quadrilateral. If you look carefully, it's all formed by chords, just like this is, which means when I add these two opposite angles, they equal 180. And when I add these two opposite angles, they also equal 180. So I know that, for instance, 10x plus 16y plus 6 equals 180. And I know also that 4 plus 18y plus 10x minus 6 equals 180. Now if they're both equal to 180, then I can safely argue, remember transitive property, that 10x plus 16y plus 6 equals 4 plus 18y plus 10x. What does that mean? Well, conveniently enough, because I have an x and a y and an x and a y, I shouldn't be able to solve this because I only have one equation. But I have a 10x here and a 10x here, and if I subtract them, they actually cancel out. Which means if I were to subtract 16y, let's say, then I'd get a 2y over here, which means I could then subtract a 4 here, and I get this rather innocent looking equation that tells me that 2y equals 2 or that y equals 1. Now if I know that y equals 1, then I know I could plug that in to one of these two equations when it's equal to 180 and then figure out what x is. So that would mean then If y equals 1, then I know that 10x plus 16 times 1 plus 6 equals 180. I just happen to pick this equation. Doesn't matter which one you pick, they both should work out the same. So what does that mean? 10x plus 16 plus 6, well, I can subtract that, so that's 180, no, 108, 180 minus 16 minus 6, which is 158, equals 10x, which means x is equal to I got the right question. Yes. Which means 10x equals, sorry, x equals 15.8. Something seems horribly wrong here. Let me just double check something. Plus 6, plus 6, 16, yes, yes. 2y, 2, I'll buy that. Okay. Yep, it's not pretty, but there it is. So I'm not going to do problem 16. Don't worry about it too much, but the same principle applies, as in these will add to 180, these will add to 180, and then what you can do is, just like we did in this last problem, set them up. Consider problems like 15 and 16, especially challenge problems, so don't worry about those too